Hello everyone, hopefully you're doing well. In this video, we're going to start with chapter 2 for quantitative reasoning. This chapter, we're gonna start with the study of quantitative problem solving. So approaches to solve problems in which the problems involve words and numbers. Remember in mathematics, what we covered already in the past. It might seem that mathematical problems involve only numbers and symbols, but the mathematical problems that you encounter in real life, in jobs, your daily life, are almost always posed with words. So, it can be also some logic or critical thinking. But in this one, what we're going to do, we would start with the studying of the approaches to solve problems. In general, when you need to solve a problem, the first step is to understand the problems. You must read the problem multiple times in order to understand it. If you don't understand the problem, you cannot solve it. So that's what we're gonna see here. In order to solve a problem, you need to understand the problems. You read it multiple times. You identify the facts, what is given, and what they ask you to do. Once you can identify these two, you can translate the wordings into a mathematical models. So once you translate it into mathematical models or formulas, you can solve, you state the answer, and you explain the result. So that's what we're gonna do in this first section of chapter 2 about approaches to solve problem solving. The first thing, the twist fundamental steps to solve a problem. You need to understand the problems. Well, first of all, before you understand it, you need to read it, right? Problem solving is more than an art than a science because there is no one method that would work for every problem. So that's why it's important to read it multiple times in order to understand it. You need to ask questions in order to identify what is given. So, what you need to do to understand the problem, you need to think about what the problem asks you to do. You need to remember that drawing diagrams can often help you to make a sense of a problem. For example, if they ask you to find the perimeter of a triangle, so it's important to draw a perimeter. A perimeter of a rectangle, sorry. If they ask you to find a perimeter, first of all, drawing a rectangle is important so you can identify the length and the width. And perimeter at this point would be two times the length, or plus two times the width, because you need to add all the side. But drawing is very important at this point. You need to ask yourself what the solution should look like. So if you're looking for perimeter, would that be in square units? Would it be only in feet? Would that be in miles? Would that be in kilometer? Would that be in kilogram or ounces? Of course, you need to understand. You need to make sense of it. You need to try to map a path, either mentally or in writing, that would lead you from your understanding of the problem to its solutions. As you move to one step from one step to another, that means like you move from understand the problem to solve the problem. Of course, you need to go through this pathway. You translate what you have, what are you given, and what you asked to find into a mathematical models. As you do that, continually revisit your understanding of the problems. Now, once you do that, the second steps of the problem is to solve it. Now you have a mathematical models. Let's say I know perimeter for now. That's my mathematical model. Perimeter is length. If you want to write it the other way around, you need to add all the side, length plus width. So you can add the 2L plus the 2W, or you can factor the 2 and times L plus W. So as you're planning on doing that, first of all, you obtain any needed information or data. That's what we did. All right. It's because you solve once you believe you understand the problem and have a path to its solutions, carried out the required steps and calculations. It all depends on what you want to do. You can obtain any needed data. For a multiple steps problem, be sure to keep an organized, neatly written record of your work, which will be helpful if you later need to review or revise your solutions, right? And you need to double check each steps as you work to avoid carrying errors through the end of your solution, because it's very important to verify that all the time. Continually reevaluate your plan as you work. If you find a flaw on your approach or your understanding of the problem, return to the first step and revise your plan. So it's always important to do that. Now, for examples, if I know what is the length, let's suppose I know they tell me length is 8 and width is 5. I mean, the width is 5. So I know my perimeter. Remember, we said we can do 2 times length plus width. So it would be 2 times 8 plus 5. That would be 2 times 13. So I know my perimeter at this point would be 26. 26 what? Maybe that would be 26 feet. What should do think? So it would be units, not square units or cubic units. So it would be 26. So let's suppose I have something like that, okay? I know we go backwards from this. But, once you solve the problem, the third step is to explain the results. You have your answers now. Are your answers the solutions? Although many people neglect this final step, it's arguable the most important. After all, a result is useless if it is wrong or misinterpreted. Right? If you will gain confidence in your results and you can explain them clearly, that of course do so. Be sure that your result makes sense. Once you are sure that your results is reasonable, and it's a good idea to recheck your calculations on once more. Or even better, find an independent way to check your results. Identify and understand any potential sources of uncertainty in your results and write your solutions clearly, concisely, using complete sentence, right? To make sure the context and meaning are really clear. So those are the steps. It's a summary of all the steps, but if you usually we put 5 steps, like on the read the problem multiple times, make sure you understand the problem, identify the facts and what is given and what is asked you to find, translate all of this into a mathematical models, solve the problems, find the answers, state the answer and explain the results, right? State the solutions and explain it. Now, we can argue about it in different ways of doing so, but let's go very quick over a few examples. In this one right here, it is ask us to write out the 3 step of the understand, solve, explain process when answering the following questions. So, understand, solve, explain. A child's inflatable pool holds 15 cubic feet of water. So if we put 15 cubic feet, usually we would write it like this, cubic feet, right, of water. How much does the water in the pool weigh? And well, they said, now, weight, right? Weight can be in what? When we talk about weight, in the US, I believe when we talk about weight, everyone expects you to express this into pound or ounces, right? So now the good news, they tell us 1 cubic feet is equal to 64.2 pounds, right? So we can put pounds like this. Well, then once we understand this, we can translate it into a mathematical models. So it is clear that we can take 15 cubic feet. If we want to translate it into pounds. If 1 pound is 64, if 1 cubic feet is 64 pounds, well, 15 cubic feet would be 15 times 64, right? So remember, it would be times 64.2 pounds for 1 cubic feet. So for us, we can cancel cubic feet. So that's why you end up with only 15 times 64.2 pounds. When you perform that operation with your calculator, I try to do it right now with my calculator. What I find, you can correct me if I'm wrong, 963 pounds. So 15 cubic feet of water is equivalent to 963 pounds in terms of weight. See the other examples. I think for the other examples, they ask you to do the same, right? They are how fast does Earth rotate? Right? Well, they said how fast the Earth rotate. Remember, Earth if it's a circle, right? You said how fast is rotated. How fast is rotated? I try to graph it to make sure that, but rotate about what? Oh, they give us some information. They said in one full rotation of Earth, a point on the equator travels 25 miles in 24 hours. Well, how fast it's rotated? I think, do we feel like the answer? I need to verify these questions and make sure it doesn't tell us what it on time. But you know what? For these questions, all we need to remember is that 24, 25,000 miles in 24 hours. But how fast is rotate? I would say per hour. If you divide this and set it per hour, it would give you 1,041.7 miles per hour. So the Earth rotates 1,041.7 miles per hour. Remember, in the US, we always talk about mph, miles per hour. In some other countries, we use a different units that we call, for example, kilometer. Here in the US, we go with miles. Another examples we can follow at this point would be, this write out the 3 steps of the understand, solve, explain process when answering the following questions. Show operations and unit clearly. Well, unit is not that, that's something we can deal with because for this first example, they ask you how much will you pay for 2.5 pounds of apples at, well, if 1 pound costs $1.25, how much would be 2.5 pounds? What would you do? Yes, you got it. You need to multiply. If 1 pound costs $1.25, 2 pound point five would cost one, you need to multiply it by 2.5. All right. So for us, we're gonna do 2.5 pound would be because we know it would be $1.25 per pound. As you know, if you cancel pound, usually that's how we do. We're gonna have 2.5 times $1.25. If you multiply these two, your calculator would give you something like $3.3, 3.13. So if 1 pound costs $1.25, so 2.5 pounds will cost $3.15. I may leave the other one for because they said if you are paid $420 for 23 hours of work, what is your hourly wage? How would you do that? Yes. only to, if you get paid all of this for 23 hours, so you only need to divide. Dividing 420 by 3, you get paid what again? Can you check that? Yes, $18.26 per hour. 18.26 per hour. Okay? That's not bad, right? That's not bad to get paid like 18.26 nowadays, all right? So those are a few examples. But one thing you need to verify after we talk about the 3 steps to solve problem, this 3-step problem solving process, it's about the units, right? Units is very important, Uh, in the examples, as you can see, we use, I think the first one we use feet, right? And pound. So, but did we talk about units? Yeah, because units is important, all right? Uh, the units always associate with the numbers. The units of a quantity describe what that quantity measures or counts. So that's how we define it right there. Okay? So that's very important to check about this because the words that describe what we are measuring or count, such as apple, dollars or hours, we call it unit. Because if we said it would take me 5 to finish, it will take the 5 what? Is it 5 minutes, 5 seconds, 5 hours, 5 days, 5 weeks, 5 years? Those are units. If I said 5 days, days is units. So the units of a quantity describe what that quantity measures or count. The same, unit analysis is the process of working with units to help solve problems. All right, so we're gonna do unit analysis. It's really powerful techniques that can offer help you to map the path to a solutions. Very important to think about it. So we're gonna have a chance to go back on the unit analysis, but let's do another examples of this. Show clearly what your use of units for the following calculations. All right. So what we're gonna do in these examples right there is to make sure we show some of the units we use. A storage. Let's go with A. I like A. A storage pod has a rectangular floor that measures, oh my God, we have a rectangular pad that measures 20 feet length by 12 feet and a flat ceiling that is 8 feet above the floor. So that would be kind of the height. So for us, in these examples right there, we can consider that we have the length 20, we have the width 12, but we have the height 8, right? Find the area of the floor. Well, very easy for us to find the area of a rectangle, right? What is the area of a rectangle? Yes, the area of a rectangle is length times width. So 20 times 12, that would give us what? 20 times 12 give you 240. 40 what? Is that meter? Is that feet? Is it inches? Is it yard? Because it's 20 feet times 20 feet. If you have feet times feet, it give you what? Square feet. So that would be the area. Okay. Now, what is the volume of a rectangle? So you need to remember that the volume, you need to have a formula for it, is length times width times height. That means 20 times 12 times 8 give you what? When you multiply it, 1920. Is it square feet, cubic feet? Yes, it's cubic feet because it's volume, right? I'm not gonna do all of them, but this is one of the examples that you can start with, and from here you can move forward and do the other ones. As you can see, all the other ones are the same. The second one give you the width, the length, and the height, right? A warehouse of 60 yard, you see all of them the same, okay? Now, um, maybe we need to do C. Let's do C. Okay. I do A and C and leave the other two for you because they only ask you if you have the area and the height, you can find the volume as well. The C said a warehouse is 60 yards long. Now we're dealing with yards, right? A warehouse is 60, right? A warehouse is 60 yard long and 30 yard uh wide. I mean, we have the length 60, we have the width 30, and we have the height 6. Now, again, what they ask you to find is the area. When they ask you to find the area in this case, it's length times width. That means 60 times 30. If you multiply, that gives you 900 square feet. Remember, area is always in square units. Volume is always in cubic unit. Now that we're done with the area, because length times width give you the area of the warehouse floor, how about the volume of the cartons? Because they said that if the warehouse is filled to half its height, what is half of its height? Right? Half of his height. So that means we still have everything correct, like we have the 60 for the width, for the length, 30 for the width, but the height would be what? 3, because half of its height. With 30 pike box, what's the volume? So we know volume would be length times width times height. Now, 60 times 30 times 3 would give you a number. So what is that volume at this point when you multiply them like this and you divide by 2? It's 5,400. Is it square feet? Oh my God, I put square feet right there. It's square yard because everything is in yard. Right now, cubic yard. Yeah, I know. Trying to go as fast as possible because we know it's important to meet the expectation instead of the time we spent for this. We're gonna go with another examples you would probably like. We said write out the 3 steps of the undestined solve expense process when answering the following questions. Do I do it twice, I believe? No, no, I'm not sure we did that one already. So for this one, what we're gonna do is answering the questions. What is the total cost of 1.2 cubic yard? What is cubic yards then? Is it area? Is it perimeter? Yes, it's volume because we said cubic, right? The volume would be 1.2 cubic yard. Okay, remember that. Now we're dealing with cubic yards, so that means it's important to remember what it is. Okay, so what we're gonna do, we said, what is the total cost of 1.2 cubic yard of soil if soil sells for 24 dollars per cubic yard. So, you know, if 1 cubic yard costs $24, you only need to look for the price for 1.2, what would you do? Yes, yes, yes. You need to convert 1.2 cubic yards to dollars by using the conversion. One cubic yard equal $24. That's it. So that's how you're gonna find 1.2 times $24 when you take your calculator. This one would give you how much? Let me try it with my calculator. That would give you, for my calculator, $28, right? And 80 cents. That's an example. So we're doing A. The same times, I believe you can do B with no problem. But if we try C, that's A. Let's try C. Oh, sorry. I put a different letter. Let's try C. For C, all right, we're gonna do C. For C, we said the cost. I mean, if your car gets 32 miles per gallon, how much does it cost you to drive 30 miles when gasoline costs $2.55 cents per gallon, right? So that's what we need to do. The cost to drive 30 miles, right? First of all, you know 1 gallon give you what? Well, 1 gallon give you what? 32 miles, right? Now, if you want to drive 30 miles, you only need to multiply this by $2.55. So what you need to see here, there is a way you can cancel out the miles, right? That means what we do here is multiply 30 with 2.55 and divide it by 32. So that gives us 30 times 2.55 divided by 32. So that's how. Remember, miles is gone, then we're gonna have only dollar left. Okay, so let me grab my calculator. 30 times 2.55 divided by 32. That gives you $2.39. Right? So I did this two for you. Please, if you don't get it, stop the video so you can go over it again on your own. And I'm pretty sure you're gonna enjoy it. You're gonna enjoy it. But one thing we talked about, and I don't want to skip, of course, is you know, the unit analysis problems, right? Well, when you say unit analysis problems, you cannot add or subtract numbers with different units, right? I cannot add mango to apples or rice to beans, right? But you can combine different units through multiplication, division, or raising to a certain power. That's what we do here. It's a divisions when we do 1 gallon give us 32 miles. We don't add them. That's the divisions, right? It is easier to keep track of units if you replace division with multiplication by the reciprocal. For example, instead of dividing 60 seconds, give you 1 minute per minute, 60 seconds, because right there is 60 seconds per 1 minute. So we can multiply by 1 minute over 60 seconds. So you see, so if we want, we're gonna cancel very quick with that. When you complete your calculations, make sure that your answer has the unit you expect. If it doesn't, then you've done something wrong. You need to verify again. Remember the process of solving problems. Always read the problem multiple times, understand it, identify the facts, what is given, what's asked you to do, translate it into a mathematical model, solve the problems, verify, check the answer, state the solutions, very often. That's what we do, provide the answer, the results. Keywords and operations with units. Usually we said one, 32 miles per gallon is like a divisions. Of or hyphen is always multiplication. 30% of 200, so that's a multiplication. Square, that means you raise to second power. Cubic or cube, you raise to third power. So make sure you review those because that's extremely important in multiplications. And review your common factors when you add fractions. If fractions the same base, like 1/3 plus 5/3, that make it same denominator you keep, you add the numerators. So that give you 6/3. So it's 2. But if we give you 1/3 plus 3/2, now they don't have the same denominator. Common denominator would be 6. Remember that. You need to whatever you do with the bottom, you do it with the top. So that would give you 2/6 plus 9/6 give you 11/6. So review your fractions. Same base you add the numerators and keep the denominator. Do not change it. Uh, Different base, different denominators. You look for the least common denominator. All right. So things we covered in elementary and intermediate algebra. Let's solve the problems very quick. On the unit analysis, we said that for these particular examples, all right, we're gonna go and do as much as possible with these. Sorry for that. Give me a few seconds for these examples. We said the average, okay? The average persons need 100, right? The average person needs 100, 1,500 calories per day. A can of Coke contains 140 calories. How many Cokes would you have to drink to fill your daily calorie needs? So remember, you need 100, you need 1,500 calorie per day. But we already said one Coke has 140 calories. So how many Coke you need to drink? Would you multiply or divide here? What would you do? Yes, you need to divide. Because if you multiply, you're gonna need more Coke. It's like you're gonna say, how many Cokes you're gonna no. If one Coke has 140 calories, divide the number of calories you need by the number of calories in one Coke. Then once you do that, it would give you a beautiful number. I believe the correct answer for you, if you drink 10.7 Coke per day, 10.7 can of Coke per day, right? So you're gonna get the 1,500. Of course, strongly not advise you to do it, but this is only an example. So I'm hoping not none of you would sit and drink like about 11 can of Cokes every day. So this is just an example. But most of all, most of the time, what we are asked to do is to convert from one unit to another. For example, in real life, we usually need to convert our feet to inches, or we need to convert our feet to yard, or we need to convert day to years, or weeks to years, or hours to minutes. We need to know what it is. So There is, you can find tables online. You just Google and find some tables. One day is 24 hours, 1 hour is 60 minutes, 1 minute is 60 seconds, 1 hour is 3,600 seconds, 1 year is 52 weeks, right? And 1 year is 365 days, so there's so much you can do converting from one thing to another. So if you are 18 years old, you can decide with you decide, you know what? I am 18 years old, but if you want to know how many days your 18 years is, you simply need to multiply it with 365, and it would give you 6,570 days on Earth. Instead of saying someone, I'm 18 years old, you can say, I'm 6,570 days old, and everyone would understand that as well. So that's at some point where we start, where we're gonna go with that. The units is very important. For example, if we ask you to convert 9 feet into inches, 1 feet is 12 inches, right? So if you have 9 feet, is 12 times 9, okay? So you need to multiply these two, all right? So it would give you a number. I believe that would give you 108 inches, right? If you have 9 feet, 9 feet is 108 inches, right? Of course, you can verify those, and I even have more for you. If you have 32 feet, remember 32 feet, 2 inches, 1 feet is 12 inches. So you can do it by 12, and it would give you a number. What number that would give you eventually, if I grab my calculator to see how many this one would be, we multiply 384. 384 inches, right? Feet to yard, first of all, you need to remember that 1 yard, when you convert feet to yard, 1 feet is 3 yard. All right. So 1 feet, no, 1 yard is 3 feet. Sorry. Yard is longer, right? 1 yard is 3 feet. So if we're looking at B and they ask you to convert 16 feet to yards, all you need to do is really take your 16 feet and divided it by 3, right? It's gonna give you the number of yard. So it would be 16 divided by 3 is 5.33 yard. 5.33 yard. Okay. So what I want you to do is make sure you can cover. Look at that. You have 35 minutes in second. 1 minute equals 60 seconds, right? So if you have 35 minutes, what you're gonna do to find it in second, right? Multiply it by 60, right? So if you multiply 35 minutes by 60 seconds, it gives you 2,100 seconds, right? And etc. You can convert hours because I said 1 hour is 3,500, 3,600 seconds. 4 times 2 times 2,600. So I'm pretty sure years, 1 year. How many days is 1 year? Right? Let's say F. How many days is 1 year? 1 year is 364 days. For us, it's taking 4 times 365 to put it into days. Now, having, okay, let me grab my calculator. If you have 4 years times 365, suppose we got it correctly. So we have 1,460 days. Now, how many hours in one day? 24. So if you multiply this one by 24 hours, so multiply by 24. So you know for the 4 years. Oops, why? I need to fix it. Okay. You know 4 years is 35,040 hours. Yeah, we did it, right? Some other examples very quick, probably you would like. Conversions with unit raised to power to powers. So you see that 1 yard, okay, is 1 yard is 3 feet. 1 square feet, 1 square yard is 1 yard times 1 yard. So 3 times 3 is 9. 9 square feet. So 1 square yard is 9 square feet because you can multiply them. We can also convert to currency. Like usually when you travel, you can take any examples of these. So that means when you travel, you can convert your US dollars to euros, European euros, or Canadian dollars, or Mexican pesos, or Japanese yen, or Haitian goods. All you need to do is all depends which units you want to start with. Your dinner in London costs you 82 British pounds. So if you want to know this one, in if for any by any chance you want to know this one in US dollars, all you need to do, take your 84 pounds. For example, in this case, you take your 82 pounds, you multiply it by the currency for US dollars. So if from the previous tables, that's an example, right? One pound, 1 pound is 1.62 US dollars, right? So all you need to do is multiply that, right? Multiply by 1.62, all right? And that's it. 1.62. All right? You're gonna know how much money you're gonna do. So you do 1.6204. Okay? Then you're gonna find it. And I would really let you to enjoy the last one because this is something you would figure it out on your own bike. Like two friends take a 3,000 mile cross country trip together, but they drive their own cars. Car A has 12-gallon gas tank and average 40 miles per gallon, and car B has a 20-gallon gas tank and average 30 miles per gallon. So when you take those examples, I'm pretty sure that you can solve them because that's not doesn't look like one full tank gas for car A would be the what? One full tank gas. Yeah, if you take car A, one full tank gas, remember 12 gallons, okay? 12 gallons, and they said, assume both car drives an average of this, it has 12 gallons and an average 30 miles per gallon, right? So if you fill the first tank for $2, because they said assume both car pays an average $2.55 per gallon. So we're gonna take car A would be 12 gallons. It takes with $55, 2 times $55, because that's the maximum it can take. So if you multiply, it's gonna give you $30.60. That's car A. But car B, all right, remember it's a 20 gallons. So we're gonna take 20 times 2.55 would give you what? If you take 20 times 2.55, it give you $51. So a full tank for car A is $30.50. A full tank for car B is $51. So that's where you're gonna start. What is the cost of one full tank for A and B? You already answered. How many tanks of gas do cars A and B each would trip? But remember, car A do 40 miles per gallon, right? So you simply need to verify that we use 3,000 miles. So if you do 3,000 miles, divide by 40 miles, because you do 40 miles. Remember, if you do 3,000 miles divided by 40 miles, if you divide this, let me see with my calculator, what would that give you? 3,000 divided by 40. All right, so that's already give you 75. Now that you know um, it's 75 because we gallon. Now you need 75 gallons. So how often you do that? You do it every 12 gallons. So this one would give you 75 gallons in total you need, okay? Divided by 12. If you do that one, your calculator should give you 6.25 tank, full tank, right? You're gonna do with car A and follow this the same example to do for car B. In a different video, we're gonna cover the second section of this chapter, approach to problem solving. But in this case, we're gonna talk about extending unit analysis. Hope this one helped. I'll see you in a different video. Take care.